Here's a problem on calculating the work required to do something. It's from section 5.5, number 16. A chain weighing 5 pounds per foot hangs vertically from a winch located 16 feet above the ground, and the free end of the chain is 3 feet from the ground. Find the work done by the winch in pulling in 4 feet of the chain. So let's see if we can't sketch that problem out. I've got a winch up here, and then the chain comes down. Now the winch is, if I had my axis here, the winch is 16 feet above the ground, if I put the ground at 0. The chain ends 3 feet above the ground, and then I'm supposed to somehow raise it 4 feet. So the end of the chain is right here, then it's supposed to go to there. Well, you remember that work equals force times distance when the force and the distance are constant. What's changing here? Well, I suppose as the chain gets shorter, there's a different amount of force that's required. So let's sort of break the distance down into very small pieces, delta y. Okay, so let's see. If the chain were ending at some length y here, and I wanted to move the chain up by delta y, okay, I need to move it a distance of delta y. How much force is required to move it? Well, the force would be equal to, let's see, in the problem we have 5 pounds per foot, so that's the force per foot. And how many feet do we have? Well, if the end of the chain is at y, I have 16 minus y feet. And you can see that the units cancel there. And so I have, let's see, 5 times 16 is 80 minus 5y pounds of pressure when it's at y distance, pounds of force required. So I have to move it. Of course, my delta y in the integral becomes dy. And I have to move that y from 3 to 7. That's the work required. This is the force times my distance, my incremental distance. Okay, so this should be a pretty nice integral to work with. Let's see, 80, the integral of that is just 80y. The integral of 5y, y becomes y squared, so I get 5 halves y squared, evaluated from 3 to 7. Might take just a little bit of work. We'll plug in a 7 there. 80 times 7 is 560 minus, let's see if I put in a 7 there, it's 49 times 5. Maybe I don't know that off the top of my head. 49 times 5 is 45, 24. Okay, so we've got 245 over 2. Then I've got to subtract from that, plugging in 3 into this number. So that's 240 minus 9 times 5, which is 45 halves. So 245 minus 45 halves is going to get me, let's see, so 56 minus 24. Maybe that's what I should do first. That's 320. Then this is actually minus a negative, so we could think of this as minus 200 halves, or 100, and that equals 220 foot-pounds, right? Because this is in feet, and the force was in pounds. There you have it.